Perth Linux Users Group, talking Linux and open source.
Plug meeting. So I guess, well, you're already here, so you know that we're upstairs. But that might be a surprise for some of you. We'll actually be upstairs next month as well. So next month is going to be a different day and upstairs. So that's going to be a little bit of a surprise for everyone. It'll be on the Monday because the person we've got speaking is only available on the Monday. That's Paul Fenwick, who is from Melbourne. Is it Melbourne? Eastern State somewhere. He's an absolutely amazing presenter. We've had him a couple of times before. If you want to go and watch some of his videos, he's very, very lively. So if you want to come along next month, that's what will be there. But this month we've got James Henstridge from Canonical, who's going to be talking about deploying apps on Ubuntu Snappy Core, which I think sounds absolutely fascinating. I'm really looking forward to it because I've heard a little bit about it. Yeah, sounds really good. So I'll pass you over to James, and thank you all for coming along.
Okay. So yeah, as I do work for Canonical. My day job isn't actually working on Snappy. Most of the time I'm working on the Ubuntu Phone project. So that's I just started the calculator there. But anyway. Snappy is kind of an evolution of some of the work we've done on the phone. So I think probably a lot of the work which we've been doing on mobile and other systems sort of started around 2012 with a port of just the standard Ubuntu desktop to Nexus 7 tablets, which was kind of pretty cool for the time. You got a full Ubuntu desktop and you had to sort of running the accessibility keyboards and stuff, which it kind of worked, but it's not really the interface which we wanted for access on most mobile devices. So that sort of evolved through to the Ubuntu Touch project, which developed a new user interface based on Unity 8, which is what's on the phones which we've been selling for this year. And Snappy is kind of a further evolution which just went and basically got rid of the UI completely from Ubuntu Touch, but kept all of the other stuff which we developed for the system. So in essence, we've got a small core operating system which has the update system and a new version of the packaging system and a few other bits and pieces which we found on which you find in the Ubuntu phone system. So let's see. I suppose one of the biggest things to note about Snappy is that it's not a full replacement for your standard Ubuntu desktop, because for one thing, it's not a platform which you're going to be using to do development. In that way, it's kind of like Android or iOS in that you need some other system to do the development, and then you deploy the applications onto this system. One of the other big differences you'll notice if you're used to most Ubuntu systems is that it works with a read-only root file system. So when you actually want to install applications onto it, it doesn't mix in with the base system at all. The applications get installed onto a different partition, and they can't sort of replace files or anything like that. There are different.
They always have routers do that. Yeah, we did that because we wanted to, not because it was meant to be.
There are. There's various things which we gain from having the root file system that way. But anyway. So some of the use cases for Snappy, there is images which you can use to run this in the cloud. If you just want a very small system, where most cloud systems, if you're running something in EC2, often you only want a small amount of the operating system, and the rest of it's just going to be your application. So this is kind of a very small amount of Ubuntu which you can then deploy, have deploy your application on top of, then that's good. Another one possibility which some people have been looking at is using Snappy as a base for a router and Internet of Things devices. And I know some people have put together some drone copter systems running Snappy. Now, I guess the main thing that Snappy is going, I mean, people have been running Linux and stuff on these other systems. So I guess the question is, what would Snappy bring to these cases? I guess the main things are you've got a base system which is common to multiple devices. So, well, apart from architecture, so you're obviously running different binaries on your x86 versus your ARM systems, but the base system is going to be the same, and you've got the ability to extend the system via installing extra apps onto it. So I mean, you've probably gone through looking at your Netgear versus your D-Link routers, and you see this one has support for DLNA, and this one has a nice print server which works. It'd be kind of nice if you had just a system where you could pick whichever router has the Wi-Fi which works the best, and then you could just pick and choose those applications and install them onto the device without having to care which treat them as features of the device itself. So that I think that sort of could make it be a game changer for some of these devices. So we'll see how things go in the future. Yeah. So if you go to that, there's a page which sort of gives some information about how to sort of get started with Snappy, and there's images for x86 and also for a few devices. So in particular, I got I picked up a Raspberry Pi 2, won it at the Plug Quiz Night, and so I've just sort of been running Snappy on that. It's just sitting on the table there. I'll demo some of that later on in the talk. But yeah, if you do install Snappy onto the Raspberry Pi 2, basically we've got a system image you can download and then just uncompress and DD onto a SD card, and you'll end up with a system with 4 partitions. There's the boot partition, then two system image partitions, and then the remainder of the space on the SD card will be the writable partition where you store all of your apps and user data. And if you do log into the system, the fstab file sort of shows how some of this read-only system works. So essentially, there's a number of bind mounts which take certain locations and link them through to the writable partition. So we don't do things like make the entirety of /var writable. There's just a few locations under there and things like that. No, it's just a straight bind mount. So do you know mount? So it's just those writable locations. Yeah, so they just overlay, and you don't see it. Those particular locations aren't present on the system image. So one of the benefits of having the whole point of having the root file system as read-only is to allow transactional updates. So when you're running the system, it boots off that boot partition and mounts system A as your root file system, and you've got that up and running. Now, let's say that there is an update available for the base system. That can be distributed as a binary diff to the previous image, and you essentially take a copy of system A, stick it on the system B partition and patch it up, and then when you reboot the system, you now use system B as your root file system, and if everything boots up fine, then that's great. You're now on the new version. If it breaks, then you can go back to system A and you've still got a working system. So that sort of gives you the kind of security which you want to have on embedded devices with minimal ways of interacting with them. I mean, you don't really want to be pulling out a serial console to plug into your router because the latest update broke it or something. So that's I think that's sort of a fairly useful feature. We haven't been doing that kind of thing on the phone images because most people seem to want to use all the storage, advertised storage for their own files. So it's sort of a trade-off. But I think for a lot of the embedded devices, having the extra peace of mind is probably worth it. So as I said, rather than mixing all of your applications into the base image, so like most Linux systems you'll find you're splatting your executables in user bin, your libraries under user lib, and mixing these all in with the base system. With Snappy, your applications are all installed under the /apps tree, and it'll go in a directory for the package, and then another subdirectory under that which represents the version. And again, this allows you to do your transactional updates of applications because you just download the new package and install that into its own version directory, and then you update a symlink just point at the current version, and you're done with a new application. So, and again, that allows you to roll back in the same way because don't delete the old application immediately, and you can go back even if you screwed up your network access or something like that. So again, there is space made available for the applications to store system-wide data and per user data because unlike the phone where it's often going to be single user, some of the devices you might want to run Snappy on will often be multi-user, so it supports that out of the box. So. Now, if your application provides some executables, then they'll be added to the path using a wrapper which ensures that the correct security confinement protocol profiles get applied. And it's also possible for the application, for the package to provide a service which will be managed by systemd, which again will be confined by the appropriate security profiles. So as well as your standard application packages, there's the ability to have frameworks. So in general, most applications are going to be self-contained, so anything which the base system doesn't provide, they provide, it comes as part, they embed all of that stuff into their own package. So if you're using a particular library which isn't in the base system, you would have that in your package. Now, frameworks are for the case where you might have a number of applications which are making use of a particular features which aren't available in the base system, and this essentially allows you to augment the system. So this might be providing libraries, it might be providing certain services which they can talk to, so like maybe a dbus daemon or something. It can also provide policy fragments so that applications which say they use the framework will have their security confinement updated so that they can access whatever the framework installs. So we've got a number of frameworks in the store at the moment. So the Docker is provided as a framework at the moment. So one very simple way of getting an application running on Snappy would just be if you've got a Docker file available for it, you can package that up as a snap, and then that would be one way of distributing it in the store. It's maybe not the best way of setting it all up because then you're responsible for everything inside the Docker file, which might sort of be duplicating stuff which is in the base system, but that's there. Again, as I said, there are also other ones like there's a few other frameworks. I'll show that sort of in the demo a bit later. Yeah. So I guess this is one area which I think we've sort of improved, that Snappy has improved things over how we would the developer experience we had with the phone. For the phone, we essentially had the base Click program, which you could use to build up your applications, and it was very, very rudimentary. It didn't really provide you very many features, so you'd often have to write your own scripts to put things together, or the alternative was you would do everything in Qt Creator, which was quite nice to use, but didn't really help you if you wanted to then do automated builds or anything like that. So some of the tooling which is being developed for Snappy is quite nice. There's a tool called Snapcraft, which can be used to assemble the packages for you. You just have a single file which is using the YAML format which describes, gives some basic package metadata plus some information on how to build the how to assemble the package, and it has support for various version control systems, so you can pull your source from Git, and has support for various build systems, so AutoTools, or if you've got Python, you can have it assemble your package using pip to download the dependencies, and there's also one for Go. But at the moment, one of the main things which we don't have with Snapcraft, which was available with Click, was support for cross-compilation. So if you do want to target things on ARM, you're going to have to build on an ARM system, which maybe that's going to change in the future, but that's how it is at the moment. And the Snapcraft tool itself is only version 0.2 at the moment, so there's room for change there. So I put together a very, very, very simple application. This is a version of the cat utility, which I've written in Python just because. This is mainly just something which is, I thought there's a number of people around here who use Python, so it'll be sort of somewhat useful to see how you might do these things with Python, and it seemed like a decent way to start. So I've got that application up on my GitHub page. If you want to look, I'll have the URLs to these things at the end of the talk as well, so you don't need to sort of write them down at the moment. But at this particular one, I just had those 5 files, and that was all I needed to build up the thing. So the snapcraft.yaml file is the build, tells how to build the package. The bits at the top is the package metadata, which essentially just gets copied straight through to the resulting binary package. And the parts section at the bottom will explain how to actually assemble the package. So in this particular case, so I've got the package name, I just call it plug example Python, got the version and descriptions, and we set an icon, and then the binaries section explains what executables the package is going to provide. So in this case, it's just we're providing one command, mycat, and it tells it to execute this particular Python executable. Now the parts section says that I'm doing a Python 3 project, so this will be something which you can build with Python's distutils. I could also have said that I was doing a make project, in which case it would just run make and then make install and to assemble the package, or you can do auto tools if you want to configure make, etc. There's also Go, and if set the source location. I just set it to dot, saying that you can find my project just in the same directory as all of my packaging metadata, which is fine if you're just doing something really simple. If you're packaging someone else's application, you might sort of point at their GitHub page or wherever they store their version control stuff, and it'll download, and Snapcraft will be able to download that and assemble it. Again, as I said, it's a very, very simple program that's just copying data from their first argument and then sending it out to standard output. So, and then with all of those things checked out, you just run Snapcraft. I forgot I was going to capture the output of that, but I forgot to do that, so I don't have a slide of that. But the main process when you run Snapcraft, it'll create a staging environment where it will download the packages from the version of Ubuntu which matches the Snappy target. So in this case, it's Ubuntu 15.04. It's Vivid, and it will essentially create a chroot environment for all those packages. And then because I chose a Python 3 project, it'll also install Python 3 into that build area, and then use pip to download resolve any of the dependencies which you've got in your setup.py, and then build the application and install it into a staging area. It will then, because it's a Python 3 project and Python isn't in the base image, it'll then stage the Python interpreter plus standard library into the to be part of your package, and then install your application into the snap and set up all the metadata, and then package it all up into your Python example plug example Python underscore version underscore architecture.snap. And at that point, I just copied it. You could SCP it across to your Snappy system and install it using the Snappy tool. So in this case, I've had to say allow untrusted because the package hasn't been signed. In general, your packages get signed if they've been uploaded to the store, and then there is a web store where you can upload your packages, and then they can be made available to download onto devices. So anyway, this is a way how you can sideload the packages which you're just testing out for development. Now, so yeah, if we do want to deploy stuff onto a Raspberry Pi device or similar, you're going to need to have an ARM system to build on. This is the bit which is sort of a little bit of a pain at the moment, because I said we don't have anything that you can build these on your x86 laptop. One option here is to use QEMU to emulate an ARM system and install Ubuntu on that, but that's not particularly nice and it's a bit slow. Since I do a bunch of other work on ARM, I've been I bought a Chromebook which you can run Crouton to create an Ubuntu system. You can have an Ubuntu chroot on your Chromebook, and that provides quite a nice development system, because the Chromebook has got like 4 gigs of memory, and I don't know how fast the CPU is, and it's a lot nicer to develop on than on a phone or a Raspberry Pi. Things just can work a lot quicker. But if you don't have any of those systems, you can also just use the Raspberry Pi for building stuff as well. If you've got Snappy running on it, probably the quickest way is to use LXC containers to set up a traditional Ubuntu system inside your inside your Snappy system. This is sort of what you might want to do if you're just for doing development, because nothing inside this LXC container is going to be updated with the rest of the system, which is kind of nice if you're doing this so that you've got a development target. But and if you want to be able to update the Snappy without sort of screwing up your development system, but it's probably not what you want to have installed onto your end user systems. But so anyway, the LXC system is packaged up in Snappy already, so it's just install the LXD package, then you can point it at the linuxcontainers.org repository and then say, I want to install a Vivid container, and it will download that stuff and set it all up for you. So that's all quite simple. Were you about to ask something? Or?
Yeah, I was just wondering why you actually need a full Linux system just to run the Snappy tools.
Well, as I said earlier, the Snappy is really a development system, so there isn't any compiler in the base system.
Okay, so there's not a sort of like, this is the make bit, which does the non-graphical user interface stuff, and does the build as it were for you.
Yeah, so think of Snappy as your stripped-down server system, where you don't often install GCC and everything on your server, do you?
Yeah.
All right.
Depends.
And you don't have GCC installed on your Android phone or your iPhone, do you?
Yeah.
Right. If you're not Sam, you probably don't have GCC installed on your phone.
But for example, that example you've given has got just Python on it. So you've got no way of doing your actual development on the desktop, as it were, and submitting it to a server to do the compilation on it. Because I would see that as being a job of a server with no head on it, just to do the compilation and do it and give me back the results. Thank you.
Okay, so you can have a build system. I believe I don't know how. I believe there is some. They're experimenting with setting up Launchpad so that you would be able to submit jobs to produce Snappy packages. So I don't think this is sort of publicly available. It's sort of very, very early days, being beta test in a closed beta at the moment, and so this would have a way of producing your Snappy packages. But again, if you think of these systems as a way as a deployment target rather than your development system, the usual development process would be to build the packages, copy them on, and then install them onto the device, rather than treating the device itself as your development system.
Yeah, so actually there's three things: the development system, there's the build system, and there's the deployment target.
Yeah. So this using LXC sort of is one way how you can use a Raspberry Pi or something as your build system, your ARM build system, without having to wipe off Snappy or switch SD cards and reboot the Raspberry Pi or anything else like that. This sort of means that you can just you can run the build in the container and then just copy the resulting snap package out of the container and then install it. So it's just as I put it, it's sort of it's one of the three options which you've got if you want to build ARM things and you don't have and your main system's x86. If you're deploying to an x86 device, then things are really easy because you can just build on the desktop.
So really, you've got a requirement there for build dependencies and also for deployment dependencies, and they're quite different things. So if you were submitting it to somebody's build system, you say, okay, I want to submit it to this system. Please make sure it's got those build dependencies on it. And you could use the same packaging stuff for doing the build dependencies as you put as
Um,
put in
Yeah, well,
the run dependencies. Anyway, we've
Yeah.
got some design for you.
well, I guess the main thing is most of the build dependencies aren't going to be snap packages.
Yeah.
It's because, as I said, the snaps are the end result of the system, and yeah, in general, your package is going to be depending on the base system or frameworks, and yeah. Anyway, so as I did mention earlier that we've got there is a security policy set up. When I installed the application and I just tried to run my little cat program and ask it to take a look at the private key for my LXC package, and we get a file not found error, which is because AppArmor doesn't let my little executable poke around in the data belonging to another application. So in this way, we've got basic isolation between the applications. So you can be reasonably confident that if you install a new application onto a device running Snappy, that it's not going to be interfering with the data of another application. So if one of the applications is, say you ran a password manager or something, if you were running your own version of LastPass or something as a Snappy web service, if you install some other application on there, it's not automatically going to have access to those files. So you've got a basic level of security there. And related to this, your applications don't have access to hardware devices. So one of the other sample applications available in the store at the moment is a webcam, where if you plug in a USB video class webcam into a BeagleBone Black or a Raspberry Pi and install this package, you've essentially got an IP capable webcam which you can set up. But of course, that webcam software, the IP webcam software, will want to actually talk to dev video, so you need to punch a hole in the security profile to give it access. So it's possible to do that with the hwassign command. So, let's see. I also mentioned you can set up services. So again, this is something which I could set up in the snapcraft.yaml file. This is sort of at the same level as if I'm defining binaries. So I might have a web server, and we set the path of the executable, and we say that we want it running as a network service, which will adjust the AppArmor profile which that executable will run under, and this will generate a systemd unit file for the service, which will run it, which will launch the application under AppArmor, and it'll have it can then sort of set up listening ports and everything else. I don't know if there's anything set up to handle socket activation with systemd at the moment, but I believe that might be coming later in Snappy. I haven't really checked up because, again, most of my work time is spent on the older system, Ubuntu phone system at the moment. But anyway, so yeah, those are just some of the resources. So I guess the rest of the thing I was just going to actually just give a bit of a demo, have a poke around on the Raspberry Pi. So yeah, when you do install the system, it's set up with SSH access. So this it just has an Ubuntu user. So again, you can see this is just in the home directory. So there is the apps apps. So you can see there's directories created for each of the applications available. So which are installed. So we can, if I just ran that little MyCat example, so anyway, sorry, why is that taking long? Anyway, we sort of, it has trouble reading that file, and but see. Where are we? I think it's, sorry, the version numbers when you sideload things are set to random strings just so that to sort of distinguish packages if you install the same thing with the same version number, which is something which can't happen when you're grabbing things from the store. Anyway, what? Did I pick the wrong one? Sorry. Yes, I did. Sorry. That's those random version numbers are a bit of pain if you're trying to work out which one is the currently installed versions. What? Okay, something's going on there. All right, cool. Sorry. Yeah. So that's so it can read its own data, as you can see, and it's going to have problems reading. Yes, so permission denied. Okay. Right, I think I must have got mixed up when I was testing that thing out before. Anyway, so we've got AppArmor confinement, which prevents the application from reading stuff in other which belongs to other applications. So if we look at, this is the wrapper shell script which was set up to run that application. So essentially it defines a number of environment variables which the application can use to locate its data. And then it uses this Ubuntu core launcher script which sets the appropriate AppArmor profile and then runs the application. So let's see, there was some other thing I showed earlier. We've got, you can get a list of all the applications which are installed. So at the moment, I'd installed some of these things are just in the base system, and I installed the Hello World LXD and ones from the store, and that plug example one is just something I installed locally. So we've got the use hardware thing. This is just an example which would try to access some hardware. It's telling me that I can't access the hardware at the moment, so it doesn't do anything. And if we assign access to the to dev kmessage to the package, it's now able to access dev kmessage, and it reads a bit of data out of there and shows that that's all working now. it's possible to inspect what hardware a particular package has been given access to, and then you can also unassign it, and etc. There's also a rudimentary web interface which is packaged on the system. So this sort of gives you a graphical way you can just sort of browse through what applications you got installed. So you can say it says you've got the LXD stuff, and you can also browse the store. So it's a bit hard to see that at the moment, but it is actually loading at the moment. So we've got various packages which you can install through the web UI. So this is something which you might be useful if you're building up a headless system, such as Raspberry Pi, where you don't want to just tell people SSHN to install stuff. So yeah. We've got a mix of things here. There's some of these all robotics things. I believe these are support applications for that drone which runs Snappy. There's also some of them are hardware support packages to run Snappy on Raspberry Pi, BeagleBone, and other devices. And there's various other ones. So you could try this Clock Web UI, I think. I don't know. Never tried this one. See what it does.
Are there info pages or things if you want to see details about one of those? Like how do you examine one of those without installing?
Let's see. So there is support. I don't know if this is all hooked in yet, but there would be support for reviews and settings and etc.
Link to source appropriate?
I don't know if that's in there or not, but anyway, I think that should be showing as installing. And
So with the versioning,
yep.
do the apps have the current version and the previous version by default, and it deletes any older versions, or does it just keep every version?
I think it keeps the previous version. I don't know. I haven't actually checked what it as how far things go back. But so again, most of what I'm showing you here is just stuff I've learnt playing around with the system. I'm not actually one of the main Snappy developers. Okay, so I guess that package I never tried that package, so I don't know. It doesn't look like it's actually launched the service properly. Well, anyway, there's various things you can install through that. Is there any particular things anyone would be interested in seeing on the system? I can show on it.
Just a question. So you could use this to like quickly, if there's something for like Mumble or the chat, you could just quickly deploy the instance from the store without having to muck about and worrying about configurations, like everything's pre-configured.
Yeah.
Really for that.
So you could set these things. If someone did package up Mumble as a snap, it could be set up so that you install it and have a ready a ready to go system. Yeah.
And it's isolated in the way, so like if I had I wanted to have people have like shell accounts, I could build almost like a Cheroot environment in this, or is that not what this is for?
We don't really have Cheroot stuff for separating users.
Okay.
Again, a lot of the systems here, it's
Single user?
well, you can do multi-user.
Okay.
So like, if you do have multiple users on a system, when you install an application, I believe it's set up so that it's not necessarily installed for all users or something. Not every user has to use it, that kind of thing.
Okay.
But a lot of the security here is designed to protect the users' data from the applications and protect applications from other applications.
Okay.
Because one of the big I think probably one of the reasons why Android and iOS were so much more successful than older systems like Symbian is that the level of review needed to before putting an application on the store was drastically reduced because they both sort of use a confinement strategy which limits how much an application can interfere with other applications. So it gets down to the point where you can do these automated reviews of the applications before putting them on the store, and that's the main.
So more embedded than.
Well,
like, I think there's a refrigerator that runs Snappy, isn't there?
I think there's definitely a concept design for
think it was
the
maybe
refrigerator.
The Ubuntu fridge.
But again, it's the same thing. Like a lot of stuff on Symbian, you install an application, it can do anything. And if you got Android, while a lot of applications ask for lots of permissions, by default, they can't really do anything. And you can be fairly certain that they're not going to download your address book and send it to advertisers unless you've granted them the permission to look at your address book. And so we're kind of looking at, the idea is to sort of look at a similar approach for other systems. Like if you did want to be able to install applications on your router, you might want to install a print server or something, but you don't want to have the print server interfering with basic routing functionality or any of the other features. So that's really where the security is aimed at, rather than isolating users.
Okay, so applications. That sounds good.
If there's a problem with the latest version, you're one of the root file systems, how do you switch to the other one?
That's a good question. I don't know how I do it on the Raspberry Pi, because I guess I haven't actually looked at the bootloader because I've generally been booting this thing headless. But I believe the idea, I think for the x86 systems, it's using the Grub bootloader. And in that case, I think Grub has a feature where you can sort of say, test out this particular option once and then switch back to the default. So the usual way, if you had run a system update, you'd have a second stanza in the Grub configuration, and then you tell it to boot that once. If that successfully boots completely, you set that as the default, and then you'd be done. And if it failed, reboot again, and you'd be back to the original system. But I don't know the answer to that one. Sorry. Anyway, see, I had tried the Snake one before, so you could install this on your router, maybe. Yep. Yeah, so this Snake application is isolated from the Hello World application and etc. Yeah.
You could configure it so every time your internet goes down, you get a Snake game, similar to the
Yeah.
Chrome.
Anyway, so you can see those applications installed. You can see them when in the command line, and I can remove them there as well. So.
Say you've got the two versions of the Python script there. Can you change between them?
Probably. Sorry.
Not sure.
Again, I'm still sort of a bit new to the system. I've been playing around with putting together some packages for it, but yeah,
Fair enough.
you should take a look.
Yeah, I'll give it a go. I'll
Yeah.
install it. I'll try and update it and see if I can use a
So-
separate version.
I mean, if you don't have Raspberry Pi, a very simple one, you can run it in KVM, the x86 version of Snappy in a KVM or a VirtualBox or something, and that's probably probably easier than setting it up on Raspberry Pi, and you'll have a nice fast system. Well, be as fast as your desktop then.
So you're saying I should use this on my main workstation? Just to confirm.
That's not quite what I said, is it? So we are actually one of the things which is planned is to develop some desktop systems which would run Snappy, but again, this isn't sort of a replacement for your traditional Ubuntu system. This might be a Linux desktop which is closer to Chrome OS than standard Ubuntu. So, I mean, there's a lot of stuff which you can't do on Chrome OS, but people find it quite, they can do a lot on Chrome OS, and maybe this would sort of be a similar system. And of course, we do eventually plan to move the Ubuntu phone stuff over to Snappy as well, but that's a little way out yet. We're still sort of putting out our monthly updates, and that's still based on the old system.
Well, thank you very, very much for
Yep.
coming along, James. I really enjoyed
Yep.
the talk, and I'm going to, I know I'm going to try it out anyway.
Okay.
See how it goes. And thank you everyone for coming along. Now, something